Welcome back to my channel. As I said on my last video, if you've watched it, about the brake bias adjuster, I said that I'll be doing a series of videos around cooling and power to get more power from the car, really. So I'm going to have a go at trying to put all that into one video. Well, predominantly one video. There'll be a couple more videos, but mostly I'm going to try and get as much as I can and distill this down into one video. There'll probably be two parts to this, maybe three, but the majority of it will be in this video. So really, there's three sections to this video that I'm doing today, which is one, the objectives around more power, cooling, and stuff like that. The activities that I need to execute to get to meet the objectives, and then the results, like what are the results of doing all these activities, because there's no point in doing something unless you're improving it or your hypothesis is actually turning out to be true. So given that first of all, I'm not a mechanic. I never have been a mechanic. I'm not even a mechanical engineer. I am a software engineer, but at the same time I see this as a problem, and problems, that's my job. I solve problems. So whether it's mechanical or computer technology, to me it's the same kind of thing. You're dealing with a problem and you need to solve it. So when I say problem, I wouldn't really call it a problem as such. It's more of a improvement, should we say, because I want more power from the car, and I want the car to be more efficient. And at the same time, it's fun. It's fun to do it. So really, the objectives are, there's two objectives to what I'm trying to do. So number one is I want to lower the intake temps, and ultimately what that would do is increase the manifold pressure. So the manifold pressure is the air going into the engine, the actual air that the engine can actually physically burn. So if you're not getting the air into the engine, then clearly you're never going to go very quickly. The car's not going to be as powerful as it should be. So that's the first thing, and that ultimate goal of increasing manifold pressure is actually quite a difficult thing to achieve, because there's so many connecting things so many related things to actually achieve that. And I'll talk about that in quite a lot of detail. If you're like me, you're not a mechanic and you don't know about these things, and I'll explain a lot of it. And then the second objective is to lower the engine temps and oil temperatures, because if you have lots of air going into the car, but the engine temperature and the oil temperature is too high, what can happen, especially with direct injection engines like this Atom, which is a turbocharged car, the ECU actually ends up limiting power, so it actually pulls back. I did download the Honda Motorsport manual, because they use this engine in F3, and there's a manual out there that tells you all the parameters on their ECU, which is not the ECU in this car, but it gives you a good idea about what this engine is comfortable being at, the temperatures that it's comfortable being at. And if you can get the temperature down, then it's a win-win situation. The engine will last longer, it'll be a lot more efficient, and it will give you more power. It'll be a happier engine, and it'll be much more reliable in the end result. So how do I achieve these two objectives? There's quite a few things to do. There's actually, how many things? Eight activities, and we'll go through them one by one. Feel free to switch off if this is boring you. I find this pretty fascinating myself. But the first one is to insulate the inlet pipe, the intake silicone hose, the airbox, and the coolant lines. And the reason for that is, even though the car's put back together, I've done a lot of these activities. I'll just show a picture of what it looks like before, so you can see. The engine cover's on. This is the main engine cover here, and it's a bit of a pig to get it off, actually. So the inlet pipe it sits right above the turbos. The inlet pipe is ultimately where the air comes into the car. In fact, it goes through the intake silicone hose first, so air gets sucked into here, and then it goes. You see this little cutout here. This is actually where the inlet hose sits. You probably just see it. So there, you can see I've wrapped it in a gold tape, and I'll talk more about this in a bit. So air goes through there, and then eventually it goes through the inlet pipe. And the problem with the inlet pipe on this car is it's made from alloy, and alloy is probably one of the worst conducting metals that there are. So that's why you can get aftermarket inlet pipes for this car made from titanium or turbo or from carbon fiber, because they don't conduct heat as much. Of course, carbon fiber though doesn't like heat, so you'd have to protect it in some way if you do go down that avenue, and they're horrendously expensive. I'm talking £1,100, I think, just for a small pipe. So what I want to do is, when I say insulate, you can just see it there. I've just showed a picture of the inlet pipe being insulated. So that tape is actually a product by DEI. It's called Gold Reflect. It's quite DEI Design Engineering Inc. They're a US-based company. You can buy their products through dealers like Amazon. There are lots of shops on Amazon that sell it, and a few other places. That's the first objective. Oh, and the airbox, you can just see, just in there, you can just see the airbox, that gold thing at the top. That's the bottom of the airbox. I didn't think you could see it. You would be able to see it with all the car put back together, but you can actually. It looks kind of cool. But I wasn't going for a cool look. That's a bonus, of course. So the airbox, and then the coolant lines. If I walk around the other side, the coolant lines sit right above the inlet pipe and the turbo and the down pipe. So these are the major coolant lines here. I'll show a picture of the main coolant line that goes right above the turbo that's now wrapped. And this is a product called, it's by DEI again, and it has a like heat reflective material on the outside, as you can see, the gold. But it has a Velcro, so you can wrap it around pipes. You don't have to take the coolant lines off, which is quite cool, because I don't want to have to empty all the coolant on this car at the moment. There's no need for it. So this this product is I'll put all the links in the description on this video so you can see what products that I've used. So that's the first activity. The second one is to insulate the cold intercooler charge pipe. This charge pipe effectively goes into the inlet manifold. So that's ultimately where the air ends up. So the cold intercooler charge pipe starts here. So it comes out of the intercooler, and I've covered, so it goes all the way up, right past the turbo, right past the downpipe, and to the back side of the engine. So what I did, in addition to what I did before, was I extended it. I then bought another one. This is a DI product again. This is called a cool tube. It's a 4-inch diameter product. You can wrap it with. It's got a Velcro on it, so you can wrap it around the charge pipe. This is the charge pipe behind here, which is an alloy. It doesn't get too hot over this side, actually. When I've been doing my testing and sensors and readings and stuff, the gearbox is right below. This is the gearbox here. The gearbox does get hot, but it doesn't get massively hot. Unlike over that side, so over around there, that's where the turbo and the downpipe is. That's where all the heat is. So of course the charge pipe goes past all of that heat. So what you want is cold air coming in here, and this is where the inlet, this is effectively where the air ends up, into the inlet manifold right there. So to get an extra pressure, to get more pressure going into there, you need cold air. That's the objective. So this helps. I put some DI reflective tape here to extend it, because this is an alloy as well, to extend it into the inlet before it gets to the manifold. So number 3. And this was quite a difficult thing, actually, and it's to create a custom turbo shield and top of downpipe shield. Now you can buy these, actually. You can buy they're called turbo blankets. There are many companies that sell them, most of them in the US, and they're ridiculously expensive, actually. And the problem, I think, with turbo shield, I could do a whole video on this actually, but the problem with turbo shields is that they tend to keep all the heat into the turbo, which the benefit, of course, there are benefits to that. One is you get the turbo becomes more efficient because it can spool up faster. There was a nice university study by the Texas University in the US that did a study on a diesel engine, a fairly large diesel engine. I know this is not a diesel engine, but it gives you an idea about what a turbo blanket can offer, the benefits and cons of it. In their findings, and I'll link to this white paper. You can read it. They did find an increase in temperatures everywhere else, oil, coolant, but they did find an improvement in spool up time, not power, not more power. You'll hear that a lot of these manufacturers claim more power by installing a turbo blanket. All the research I did, that's just not the case. You don't get more power from insulating the heat in a turbo, and in fact, it probably does the opposite, because at least from my research that I've done, and the paper that was done by the University of Texas, and so what I did as a compromise, I wanted a heat shield, which is a very different proposition. This is the stock shield that's on the car that you get with this engine. So it kind of sits like that. That big hole there is the O2 sensor, and you can see it's just a piece of metal. It's rubbish, and there's holes in it, so the heat's going to come out, and right where this thing is, that's where one of the coolant lines goes, and this bit at the back, this is where the inlet pipe sits, where all the cold air is supposed to come in. So this is not very effective at all. Not only that, see where my hand is right now. That edge, I'll put a picture and show you. This edge here, the top side of the turbo is right here where my hand is. So all that heat is just going to leak out and just absorb into that alloy inlet pipe. What I decided to do was make a turbo shield. I'll show a picture of that. And I made it from another DEI product. It's a DEI former shield, which is made from a basalt product, which is basalt is a fiber or a rock that comes from lava out of volcanoes, and it happens to be a very good heat insulator. I've tested it actually using a 1300 degree blowtorch, and it is unbelievable. I'll create another video and show you how effective this product is. So what I did is I created the top of the turbo shield, and the goal of it is really just to stop the heat from heat soaking into the inlet pipe and the coolant lines, and that was really the only objective, and obviously the cold side of the turbo, and of course the oil line as well. There's an oil line that has no heat sink around it that goes into the turbo, because there's oil and water cooled turbo on this car. So that was my only objective. It's not about keeping the heat into the turbo. It's really just to keep the heat away from the other components that I don't want it to heat soak into. And then the same, although the other goal of the other thing I did was I made the same sort of thing for the top of the downpipe. It's very, very tricky to get in there and do this. The top of the downpipe is connected directly to the hot side of the turbo, so it's going to get really, really hot. So what you want to do with that is you want to keep the heat in, and you want the heat to go out of the exhaust. So the other thing I wanted to increase was the exhaust gases to exit the car much faster. So one way to do that is to stop the heat from coming out of the exhaust system and to heat soak into other parts of the car. So a common thing is you either ceramic coat it. So I looked at doing ceramic coating the whole exhaust system, including the downpipe, and the results from Secotec, they claimed a 33% reduction in temperature, which to me just isn't enough. So if you think about the measurements I've been taking on the top of the downpipe is about 250 degrees, something like that, when it's been driven hard. After I installed this stuff, this custom DEI former shield heat shield around it, the temperature went down to something like 70. So 70 degrees. It went from about 250 down to about 70 degrees. So it's incredible how effective it is. And then the rest of the exhaust system, I'll show a picture of that, what it looks like. That was, I think, if I remember rightly, it was 100 10 degrees without the shield on, and then with the shield on, it was something like 40 degrees. So it's at its peak, that is. I forgot to say that the actual dam pipe, I didn't use the former shield. I used a product by Funk Motorsport, which is a fiberglass product that you wrap around the pipe and then you secure it using springs. I did that because I didn't actually want to take the dam pipe off, and it was near impossible to fit this DEI former shield. So the other thing I did is I fitted I actually used this product here. Again, another DEI product. It's called Floor and Tunnel Shield 2, and it has an adhesive backing to it. And I stuck that on the inside, or the outside rather, of the oil sump where the exhaust sits. And here's a picture of what that looks like. And it's basically just a barrier. It's to stop the heat soak from the exhaust. Even though the exhaust pipe is already wrapped, this, as you can see, it says protects up to 1750 degrees Fahrenheit, which is pretty impressive, and it stops a lot of the heat going into the oil, keep heating the oil up. The other thing I did was I protected the fuel tank. So the fuel tank is right next to the dam pipe. Is about 2 inches from the fuel tank. I can't actually get in here, but I have pictures. I'll show you the pictures. And I use a product called Seco Flex 3, which is has an adhesive backing, has 3 layers of an alloy heat protector to stop heat soak from the engine into the fuel. So the next item I haven't done yet, and this is one of the big items. I wanted to test these things in increments, so pretty much everything on the car you've seen so far that I've talked about, I have tested, and I know the benefits, the results of it. But the big ticket item is the oil cooler. Now, this car surprisingly doesn't have an oil cooler, and I bought this one, this C-Trab cooler, which is 40 row, so it's a full width cooler, and I plan to put it at the back of the car, right at the back, behind the engine, and then the duct from the T-tray, the engine cover, will hopefully funnel air down to it. I may make a duct, I don't know yet. I have to test it and see how well it performs. And then I've used up some of this Secoflex material here to stop some heat soak from the exhaust, even though the exhaust is wrapped. The actual muffler is not wrapped. And then I've got these rubber bobbins here. These, I'm not so sure about these yet. It might be they're quite flexible. So I got these rubber bobbins because you want this to absorb all the shock. You don't want it to crack. And then I made these brackets. So I made these out of mild steel, 3mm thick mild steel, and then they're ready for painting. So I may powder coat them, and then they just fit on here like this. And then I have some 8mm rod that I'll weld from here to the chassis, and I've got these chassis brackets with rubber inserts that allow me to connect it to the chassis. So that's that. I think, once I get this installed, I think this would make a massive difference. Pretty much everyone that's done this, they see big improvement on the oil cooler. But like I say, I've got all the results from all this work I've done so far, and I'm staggered by the benefit of stopping heat soak. So that's the oil cooler. And then at the same time, because I'll be changing the oil, I thought I might as well buy a decent drain bolt. This one's from Spoon. So Spoon are a Japanese company, and this has a big magnet on the end, so it will catch a lot of metal filings. I plan to, because of the oil cooler, and to increase performance again, I'm going to change the Honda oil filter with one of these. This is HKS. This is the high performance oil filter, and it's a high performance one because it's smaller. It's got a bigger, it's bigger diameter inside than the stock Honda one. I think the Honda one they use, that's used on this engine mostly, is the PLM A02. There's a lot of people criticise that particular oil filter, whereas this one, I've not heard anything bad about it at all. This is the limited edition purple colour as well. So if you want to get this, I bought this from Dream Automotive. It was shipped the next day, so it was pretty fast, and the sump plug as well. How I plan to wire this in to the car is I plan to install a sandwich plate, and what I've got here is a sandwich plate by HEL. So this is a British company based in Exeter in Devon, and this one is a thermostatic sandwich plate. So if you're not familiar with what a sandwich plate is, it's basically the plate that goes between the engine block and the oil filter. So it go in like this, so that ring, that O-ring here, will sit against the engine block, and then I install the 22mm adapter here. There's a metric one, imperial one as well. That goes through into the engine, this way around into the engine, and then the oil filter screws into this part. And then you can see that gold bit there, that's the thermostat, and it opens up at 82 degrees. So 82 degrees, it starts flowing oil into the oil cooler. Obviously you want the oil to heat up in the engine first before you start cooling it. So in terms of the other thing about this is, I mean, it's such a lovely machined made sandwich plate. I was really impressed with the quality of it. It has these options where you can put the oil lines here, or at this 45-degree flange here. I also bought, when I bought this, I bought the optional, these plugs here. So these have a hole in them. You can just see a hole there. That's got a MPT port, and the benefit here is you can if you run the oil lines from here and here, I can have an optional sensors into both of these. So usually what you would do is put a oil temperature sender into one of these, and then maybe a oil pressure. I've already got an oil pressure on the car, on the dash actually, so I'll probably just end up installing just the oil temperature, and then I'll run I will install the oil temperature gauge right next to the brake bias adjuster. It'll be hidden back there under there, so it's nice and neat installation. I've planned exactly how I'm going to do it. There's a power source under the dash that's usually used for the windscreen wiper, so I'll use that. It's terminated at the moment, so I just unplug it, plug it in the dash, and that will connect to the oil temperature sensor, because there is no oil temp sensor on this car. So to connect the hoses, I've got these I just spent a lot of money on all this because you don't want this to fail. I bought these. This is a Goodrich 200 series 10 AN size hose, and it's a fabric braided hose. So it has, so you can see that there's a metal braid underneath this fabric. The reason I went for the fabric and not the stainless steel, so this is I think from memory, this is the 210 series hose. The 200 is identical, except this fabric is metal. The reason I didn't go for metal is because metal heats up faster. So because this is going to run adjacent to the oil sump, I didn't want these lines heating up. So the whole point of going to the oil cooler is to cool the oil down. So I went for these, and these are also more bendable, more flexible than the metal ones. And then finally, to finish it off, I got these. I need to get 2 more of these actually. These are Goodrich, again, 200 series connectors. I don't know what you call these, but they're made from aluminium, so you need a special wrench to do them up so you don't mark them and damage them, because it's a soft alloy. I've got a special vice grip actually to do them up, and a special spanner to do them up as well. And they have to be, so these have to be torqued. These are the adapters that plug into this this sandwich plate, and these had to be torqued down. These have O-rings, really well made as well, really high quality stuff. So yeah, that's oh yeah, the last thing. So this is the next job to do, to put on the car, because now I've got some data for all the cooling stuff. I've also, so what I plan to do is next to install the oil cooler and then get the data from that. What I haven't done though is been on track with it, but I have enough data now to see that this is having a beneficial impact. All the cooling work I've done so far, the oil cooler would just make everything 10 times better. The final 8th thing, this has been a long video, I know that. If you're still with me, congrats. The final thing is, you see this piece of cardboard here, this is a prototype here. I've made this is the proper one actually. This is just a template. The goal of it is to force air into the actual radiator duct. So there's a radiator duct here, right where my hand is, and it channels air directly into the radiator. But the problem is, if I remove this, I'll show a picture actually, there's quite a big gap underneath. So wind always takes a path of least resistance. It's going to go in here, it's going to hit this bracket if you've got the wings, and it's going to go over into the air duct, or it's going to go underneath the wing, and you're going to lose a lot of the wind. I've actually took this car out earlier today in 24-degree heat. So today's the 25th of September, and there's a fuel crisis. All the fuel's run out at the petrol station, so I couldn't really do much testing because I'm now down to about 15% of fuel in the car, so I couldn't really test it that much. But I saw even an impact with this, and I tested this first rather than making a bracket from mild steel. I've got 1 mil thick mild steel that I plan to make a bracket, and it look nicer than this. So you see where this tape is, it will look like this. So as this kind of folds up, it will block, because there's a gap here where the bracket is, and there's an opportunity for air to escape there. So then I will drill a hole in it and fix it, and then put some rubber insert in there along the side here to protect it and stop vibrations, and then paint it black. I think about putting some vinyl, yellow vinyl on it. That might look quite cool actually, but we'll see, because I know this is going to have an impact on it, and I've seen it already. I've seen the data already. I've seen lower ECT temps and yeah, just overall average ECT temps, even though it was a hotter day today by about 4 degrees over when I tested the car without it. But like I say, in the next video I will talk about all the results, because this one's gone on for long enough now. Cheers.